Yo, what's up, LST fam? It's your boy Simpure from LST Robotics, and today we're diving into the 360-degree lidar sensor. In this video, I'm going to give you a quick explanation of what the 360-degree lidar sensor is, how it works, and where you can use it in the real world. So, what is the 360-degree lidar sensor? A 360-degree lidar sensor uses laser light to measure distance and create a 3D map of its surroundings. It works by sending out laser beams in all directions and then measuring how long it takes for the beams to bounce back. This allows it to see everything around it in real time and with high precision. In the real world, these sensors are used in things like self-driving cars to detect obstacles, drones for mapping and navigation, and even robots for environment scanning and object detection. It's pretty cool tech, if I must say. In today's video, we'll be combining the lidar sensor with the DC motor. I won't go into too much detail about the DC motor here, but if you want to learn more, be sure to check out my previous video on Simple Auto Project. Now that we've covered the basics, let's get started. First, we'll mount these 4 legs onto the frame to get our build off the ground. This gives us enough space underneath cable management later on. Next up, I'm mounting the Titan quad and the VMX Pi onto the structure we've built. If you're curious about the components, drop a comment down below and I'll make a separate video on them, just for you guys, of course. So, once that's done, I'm going to mount the lidar sensor onto the chassis. This was a bit tricky since I don't have the 3D printed lidar mount with me at the time, but no worries, we'll make do. If you look closely, I've mounted the power and data module for the lidar underneath the chassis. Ideally, I should have mounted it underneath the lidar itself. For future builds, I'll keep that in mind. This is just me showing you that it's underneath the chassis and showing you that the power and data. Next time I'll mount it right underneath that gap. For future builds, I'll keep that in mind. I should have mounted this facing other direction for better cable management, but for this prototype, it's alright. I'll just keep it the way it is. But next time I mounted it under here. Next up, is cabling. The lidar sensor uses both micro USB and USB Type-C cables. The Type-C cable is for data, while the micro USB cable is for power. When connecting them on the VMX Pi, make sure to use the USB 2.0 port. I also moved the VMX Pi forward by a couple of inches to make cable spacing more manageable. Now I'm going to add the motor and the battery holder to the chassis. I'm just deciding where to put the motor. That's where I had put it last time and it worked out perfectly, but now we have a lidar sensor on the other side, so I'm thinking of mounting the motor right there and putting the battery holder there. With the cabling done, time to clean things up a bit. Let's grab a few zip ties to organize the wires and make the robot look neater. Okay, it's not the tidiest cable management, but it works. The key is that the wires aren't just hanging all over the place and everything is securely in place. Now, all that's left is to plug in the battery and get to the coding. I think we should give this robot a name. How about Francine? Just a quick reminder, I am still a student and everything I show you here, I'm learning for the first time in my free time. So if I make mistakes, I learn from them and share what I've learned with you all. With the code now done, let's deploy it to the robot. Open the control station console and add the robot's IP. Wait for it to load. It will then automatically open the shuffleboard. I'll now move the tabs that I need to the screen and enable the robot in autonomous mode like I showed you guys in the last video. If you look closely, it shows the lidar distance and the encoder of the spinning motor. I set it up so that the robot starts detecting objects when the lidar reads around 100 millimeters and it stops when the distance reaches around 300 millimeters. If you look closely at the screen, when I put my hand around 300 millimeters from the lidar, the motor stops, indicating the robot has detected something. For us to know that the robot motor stopped, you'll see that the encoder values are no longer counting, but the lidar distance values are counting. Shortly, I will show you what that looks like. Watch this. When I move my hands closely, you'll see the wheel stops rotating. If you enjoyed today's content, don't forget to like and drop a comment down below. If you're new here, make sure to subscribe. It's completely free. Thanks LST fam. I'm out.